Topic 2, Day 2, Quadratic Functions. So what you'll see here is a parabola, and we know that the parent function for quadratic functions is y equals x squared, where the x and y intercepts are both at 0, 0. So it crosses our x and our y intercept at that origin. Here we can also see the vertex is at the point 0, 0. We'll find out later on that the vertex is oftentimes indicated using the variables h and k. So it represents an x and y component of our vertex. Our axis of symmetry is at x equals 0, right here. The domain is all real numbers. Our range is y has to be greater than or equal to 0, and it concaves up. Now we have multiple forms of quadratic functions. So here you'll see our standard form, y equals ax squared plus bx plus c, where c is our y-intercept. Vertex form is y equals a times the quantity x minus h squared plus k, where again our h and our k represents the vertex. And then we also have a factored form, where a multiplied by x minus m times the quantity x minus n, and m and n are going to be our y-intercept, our x-intercepts. Okay. So if we have our axis of symmetry, if we have it in standard form, we can use a formula negative b over 2a to find the axis of symmetry. And the x value also happens to be the x value of the vertex, right? Because wherever we have our parabola, if this is our vertex, the x component of that is also our axis of symmetry. So if we find the axis of symmetry, find the x component of our vertex, we can plug that value back into our original function and find the vertex itself, right? And that represents our h comma k. If our a value is positive, then the vertex is the minimum, the parabola concaves up. If a is less than 0, then the vertex is the maximum, the parabola is concave down. The parabola crosses a y-axis at the point 0, c, and that's a y-intercept. So we have a lot of ways that we can solve for x-intercepts, and they also have a lot of names. So if you see what solve for the x-intercept, solve for 0, solve for roots, or for solutions, all of those are synonyms for x-intercept. So the first method here is, if you have access to a calculator, you're trying to do this quickly, especially on things like the ACT, you can just graph it, right? Graph it, see where it crosses our x-axis, and those are going to be your x-intercepts, right? So here you can see we have a solution at 4 and at negative 1.5. The second method that we have is to factor. So for factoring, I'd recommend start by labeling your a, b, and c. So here is our a value, our b value, and our c value. And then multiply a times c, and we get here negative 24. List out all of the possible factors that give you negative 24 and find the one that adds up to negative 5. So a lot of times we can use this kind of x method here, where it's going to be a, c, and b. So here ac is negative 24, our b value is negative 5, and the factor that gives us negative 5 is 3 and negative 8. So we're going to write those here, 3 and negative 8, all right? And what I'm going to do here is replace negative 5x with 3x minus 8x. So again, this form right here is equivalent to our original form up here. It's just in a more useful form for us. And then we're going to cut it in half. So looking at the first two terms, they have an x in common, so I factored out that x, and I have 2x plus 3. And then in the second half, I can factor out a -4, which leaves me with 2x plus 3. And then that 2x plus 3 and the 2x plus 3 can get factored out, leaving us with an x minus 4. So we have it now in this factored form, y equals 2x plus 3 times the quantity x minus 4. We set those individually equal to 0, and then solve. Can subtract 3 to both sides, divide by 2, and then add 4 to both sides, and we end up with our two x-intercepts at -3 half 0 and 4, 0. Unless specified otherwise, it is a good habit to get your x and y-intercepts written as coordinate points. Next, we have the quadratic formula. So similar to factoring, start by labeling your a, b, and c, and then we have our quadratic formula written out here. X equals -b plus or minus square root b squared minus 4ac all over 2a. And then plug in all of your numbers and start simplifying. A couple of things to watch out for. Be careful right here that you have parentheses around the negative, right? So that we have a positive 25 plus 96, which gives us the square root of 121. And then when we calculate the square root of 121, we get 11. So 5 plus or minus 11 over 4. And then 5 plus 11 is 16. 5 minus 11 is -6. 16 over 4 reduces down to 4. -6 over 4 reduces to -3 halves. And we end up with those same two x-intercepts written as coordinate points. Okay. The last method is to complete the square. Completing the square, in my opinion, is more useful for finding the quadratic equation and getting it into vertex form, but it is one way you can solve for your x-intercepts. So I'll show it here. If you have a coefficient, a leading coefficient that is greater than 1, so in this case our leading coefficient is a 2, then we need to factor the 2 out of the first two terms. So we have x squared minus and then 5 halves x because we're factoring out. Plus some blank, we need to figure out what that value is going to be that lets us get a perfect square trinomial. And then subtract 12, and then we need to subtract whatever we add, we need to subtract so that we keep it equivalent. Now in order to figure out what value should go there, you're going to take your b value. So here is going to be -5 over 2. Divide all of that by 2 and square all of it. Okay, and when we do that, we get 25 over 16. Now what you'll notice is that I have a 25/16 here, but I have a 25 over 8 here. And the reason that that is twice as large is because we have this 2, right? So in order to account for that 2 having been factored out, when we add it inside there, and in order to subtract the same quantity, the same amount, we need to multiply it by 2, that leading coefficient that we originally factored out, and then subtract that same amount. So again, our equation is equivalent. Now x squared minus 5 halves x plus 25 over 16 is a perfect square trinomial that is equal to x minus 5/4 squared. And we can get this 5/4 value because it will always be half of your b value. So here -5 halves divided by 2 is -5/4. And then I just used a calculator to reduce -12 minus 25/8. Okay. From here, we have it in our vertex form. So in order to get our x-intercepts, we set y equal to 0. And then I'm going to add the 121 over 8 to both sides. And then divide by 2, find the square root. And then again, our plus and minus is necessary because -5 quantity squared equals 25, just like 5 squared equals 25. So here we need to account for the positive and the negative values of the square root. And then we add the 5/4 to both the positive and the negative, and then we end up with our two x-intercepts. Okay. Now, there are also a lot of questions that are going to ask you to convert from one form to the other. So in order to convert from standard to vertex form, we need to complete the square, all right? And this is the exact same example that we went through in this previous one that goes up until right here. All right, if you have to go from vertex to standard form, we need to distribute and combine like terms, right? So we're going to take the part that is squared. You can use a box method, you can FOIL, multiply that out, and then multiply the 2, right? So we're doing the opposite of factoring. We're distributing that 2, combining our like terms, and then we get it into standard form. Now the discriminant is a portion of the quadratic formula. It is your b squared minus 4ac. And it will tell you how many real solution a quadratic function has. All right, so if the discriminant is a positive value, you have 2 real solutions. Just like this first example here, you'll see there's 2 times where it passes the x-intercept, the x-axis. If the discriminant is 0, you'll have 1 real solution. And if it's negative, it'll have no real solutions. So let's go through teacher example number 1. Let f of x equals x squared minus 10x plus 25, where x is a set of all real numbers. For the graph of y equals f of x, find the y-intercept, x-intercept, x is a symmetry. And then later it's going to ask for the vertex. So when we start the y-intercept, your x value is always equal to 0. For your x-intercept, your y value is always equal to 0. So our y-intercept, we're going to plug in 0 for all of our x values. So here we're going to do y equals 0 squared minus 10 times 0 plus 25. The zeros cancel out. 0 minus 0 plus 25. We get a y value of 25, right? So we know that the x is 0, the y is 25, so that gives us our y-intercept, 0, 25. Now, in order to find our x-intercepts, we're setting our y equal to 0. Get x squared minus 10x plus 25. Looking at these numbers, it looks like something that can be factored. All right, with lots of experience, lots of practice problems, you start to gain an intuition, right? Obviously, not all quadratic functions can be factored. So if you feel more comfortable using the quadratic formula, which will always work, you're welcome to do that. I'm going to go ahead and factor. I know a is 1, b is negative 10, c is 25. And my a times c is going to be 25, and my b is negative 10. So what are my factors? 1 times 25, negative 1 times negative 25, 5 and 5, negative 5 and negative 5. And negative 5 plus a negative 5 gives me a negative 10. So I know that I have x minus 5, right? That's equal to 0. Set it equal to 0 and solve. X equals 5. So I know that my x value is 5, my y value is 0, then my x-intercept is going to be at 5, 0. Okay. And then in order to find the axis of symmetry, we can use our formula negative b over 2a. And our b value is a negative 10, so we have to be careful that we're doing a negative 10 all over 2 times 1. So that's going to be a positive 10 over 2, which is a 5. So our axis of symmetry, x is equal to 5. Right? And that is an equation, right? It's saying that is a line, x equals 5, as opposed to our x and y intercepts, which have been coordinate points, the point at which it is crossing an axis. Okay, now the last one, it says the vertex of the graph of f, our function, is at hk. Right? If we think about what we have done so far, we essentially have an equation where there's only one solution. We know it's concave up because this is a positive a value. And it has a x-intercept at 5, 0, and a y intercept here at 0, 25. So we know that this point here also has to be the vertex, right? So when we're looking at this 5, 0, 5 is going to equal h, 0 is going to equal k. For this particular problem, we already know what the vertex is. We already know what h and k is. But if we didn't, or if we had two possible solutions and we didn't know what the vertex value was yet, then you had a couple of options. Option number 1, we have the axis of symmetry, right? X equals 5. And so we can just plug 5 into our original function. F of 5 equals 5 squared minus 10 times 5 plus 25. 25 minus 50 plus 25. And then that equals f of 5 equals 0. So we'll see that our vertex point is, again, 5, 0, right? Or we could complete the square. Okay. So those are our solutions for this problem. Go ahead and try student example number 1.